Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. This is a question on error intervals. More specifically, we're going to be looking at upper and lower bounds, and we're going to be linking these bounds to answer a complex problem. Now, first of all, we need to identify the key parts of the question. So we've got the width, W, we've got 60 centimetres, and this is to the nearest centimetre. We've got 6 of these wall units are going to be placed alongside each other, and the wall is 363 centimetres long. This is measured to the nearest centimetre, the same as the width of the cupboards. And we've got to show that these 6 cupboards may not fit along the wall, and this is worth 3 marks. The key facts you will need for this question are that an upper bound is calculated by doing the value plus half of the nearest value. The lower bound is the value take away half of the nearest value. To find a maximum length, you need to add together 2 upper bounds, so UB stands for upper bound. And to find the minimum length, we do a lower bound of the first value, take away the upper bound of the second value. Now, in part A, you were given the answer to the error interval. So you had to work out the error interval for the cupboard. So I'm just going to tell you the answer to that. So you can see the answer to part A was between 59.5 and 60.5. You can watch my previous video to see where these values came from, and this gives you the error interval for the kitchen cupboard. So you will need to use this information in here, and we've got to show that the 6 cupboards may not fit along the wall that is 363 centimetres long. Press pause, have a go at answering the question, press play when you're ready to hear the answer. Well done. Hopefully you've got an answer. Give me a big thumbs up and a smiley face in the comment box if you've got an answer, and we're going to look at how you did. So, to start with, we're going to look at the wall unit, which is 363 centimetres to the nearest metre, to the nearest centimetre. So that is 1 centimetre below, which is 362, or 1 centimetre above, which is 364. And we need to work out the value in between each of those, which is 362.5, because that will round up to 363. And any value up to 363.5 will round down to 363. This is explained more in my previous video, so please look back if you're unsure where the error intervals come from. So this gives me the error interval for the wall. Now my wall, okay, is a length, and then we've got 6 cupboards. So I've got to place my 6 cupboards down against the wall, and you've got to show that the 6 cupboards that I've put down here may not fit along against the wall, which basically means the cupboards are longer than the length of the wall. So to show that this may be true, we need to look at the wall value. Now the wall value we can either use is the lower bound of 362.5 or the upper bound of 363.5. Now we want to make sure that we can show that it may not fit. So if it may not fit, we need to use the smallest value, or the lower bound. So the wall is going to be 362.5, just to double check everything will fit. Then we need to do the opposite with the cupboard. So for the cupboard, we've got a lower bound of 59.5 and a 60.5 for the upper bound. So we need to use the maximum bound for the cupboard to make sure to see if it will fit within this 362.5 length of the wall. So my cupboard, all of these are going to be 60.5. So if I add all these 60.5s together, or do 60.5 times by 6, that gives me 363. Now you get 1 mark for identifying the 362.5 and another mark for working out 363. So we've got 2 marks so far on this question. Now we need to compare these answers, and we've got to show that these 6 cupboards may not fit. So the wall, you can see here, this yellow line is 362.5, but all the pink ones combined together is 363. So if 363 is bigger than 362.5, i.e. the maximum cupboard is bigger than the minimum wall, therefore the wall is shorter than the cupboard length, therefore it does not fit, and that needs to be stated to get your 1 mark. So please make sure you have marked your answers using your purple pen. Give yourself a tick every time you see where it says 1 mark to show you've got that answer correct. And make sure you understand why the wall and the cupboard may not work, because you can see here in the diagram the wall could be smaller than the length of the cupboard due to rounding error when you were measuring the values. Now the mark scheme on this question, will show us that there are 3 marks. You get B1, which is a method mark to show where the methods are awarded. You can see there are a variety of different ways that you could have approached this question. So you could have done the length of the wall divided by 6, or the length of the wall divided by the cupboard, to show whether it gave you a value of 6 or not. There are different ways of approaching this. I just showed you one of the methods. It's up to you which way you choose to do the question. If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!